Okay, well, good afternoon, everyone. I want to welcome you to this ITIF event on the role of NIH funding in biomedical innovation. I'm Rob Atkinson, I'm president of ITIF, and despite the IT in our name, we also have innovation. And so we've long focused on biomedical innovation in a wide variety of areas, including NIH FDA drug approval, intellectual property issues, including by dole, including in trade agreements, looking at the competitiveness of the industry in the U.S., but also looking, at NIH funding and the role that it plays. So that's what we want to talk about today. There's a report that we released, I guess, about a week and a half ago, 2 weeks ago, called Healthy Funding, the critical role of investing in NIH to boost health and lower costs. There's a copy out there, also on our website. We're really pleased to have a great panel today, so I'm not going to try to be pretty brief, but I'll introduce our panelists now. We'll hear from each of them after I make some opening remarks, and we'll have plenty of time for questions from you all. On my immediate left is Paula Cohen. She's a professor of genetics and the director, Center for Reproductive Genomics, and associate provost for life sciences at Cornell University. Focuses on a whole wide array of areas, including germ cell biology, DNA repair, chromosome biology, and non-coding RNA. She received her PhD from the University of London. Next to Paula is Lila Portilla, who's Director of Strategic Alliances at the National Center for Advancing Translational Sciences at NIH, which is a relatively new institute. It was set up to, as the name implies, to translate and core NIH research into the marketplace. She's worked at NIH since 1989, joined NCATS in 2011, involved in a number of the NIH programs to move innovation out into the marketplace, including the SBIR program and the SBTT program. She received her master's degree in public administration from American University. Sudeep Parikh is a senior vice president and managing director of BIA Americas. Prior to joining BIA, he was vice president and general manager of health and consumer solutions at Patel. He led Patel's healthcare improvement, public health research, and consumer industrial medical technology development team. But also prior to Patel, he was a senior advisor to the U.S. Senate Appropriations Committee, where he was responsible for dealing with budgets related to the NIH. And he has a PhD in macromolecular structure and chemistry from Scripps. And finally, Danelle Friend is from the Director of Science and Regulatory Affairs at the Biotechnology Industry Organization, or BIO. She received her PhD in neuroscience in 2013 from the University of Utah. Was selected as a Science and Technology Policy Fellow with AAAS. Also served at the NIH in the Office of Science Policy, and then has been at the BIO since 2017. So let me start off by talking just a little bit about why it's so important to keep the momentum going for increasing funding for NIH. It's one of those, I don't say few, but it's one of those unfortunate few areas where you have really strong bipartisan consensus. Congress and Washington in general, and increasingly riven by partisan differences on a whole set of issues. But this is one where you have both parties coming together and saying this is important for us to move forward with. For example, Senator Roy Blunt, Republican from Missouri, Patty Murray, Democrat Wisconsin, from Washington, and Representatives Tom Cole from Oklahoma and Rosa DeLauro from Connecticut have both come together in the House and the Senate to really advance forward and successfully lead the charge for NIH funding. I was on a panel this morning with the Engineering Society. They have an annual fly-in to the Hill, and I was on the panel. I've done this now 3 years in a row with Steve Moore, who many of you know the president has nominated to be for the Federal Reserve Board. And Steve and I were having a discussion about innovation. We agree on some things, but Steve's, shall we say, more libertarian than I am, doesn't necessarily believe in a stronger role for federal government. But I thought it was interesting, Steve said, well, I'm not sure about funding this other stuff over here like engineering, but we all agree that NIH funding is super important. And I thought that's pretty interesting that, Steve Moore, who is very conservative, very free market, small government guy, he sees NIH funding in its own category because, number one, it's basic research by and large, and number two, it's so central to improving American health. So when we look at funding, which we do in this report, what we find is that people still in their mind have this view that, well, didn't we solve this problem? We doubled NIH funding back in 98 to 2003, and aren't we good to go? And in reality, if you look at the funding either from an inflation-adjusted point of view or from a per GDP point of view, we did, but then we had this period between 2003 and really 2014 where just NIH funding was going down as a share of GDP or in inflation-adjusted terms. And so getting NIH funding as a share of GDP back up to 2003 levels where Congress wanted it to be, doubling and then keeping it going. Unfortunately, Congress didn't keep it going. So getting it back to that level would require an additional $5.9 billion appropriations in the last fiscal year. So Congress has made a lot of strides in the last 2 or 3 years in terms of getting NIH funding up, but there's still work to be done. Well, why is that important? Well, let me preface that by saying one of the concerns that some people might have is, well, is that extra money going to be used efficiently? Is there a demand out there in the research community for, are there enough good proposals out there that we're not going to be funding just sort of, poor quality work? And the answer is pretty clear. In 2018, just 17.8% of R01 research grant application, or the most fundamental research grant application in NIH, was funded for 17.8% of that. You compare that to the peak period of 2003, right after doubling, where 24% were funded. So this suggests that we could expand NIH funding by $8 billion, $10 billion, and we wouldn't have any diminution of quality. We wouldn't be funding, if you will, mediocre research. There's another important point here, and that is the role that NIH plays in biomedical innovation. And it's one of those roles that sometimes it's easy to lose sight of the fact, but when you review the literature, there's a whole lot of studies that have looked at the role of NIH funding, whether it's at the NIH itself, in the institutes, or at universities like Cornell. What you find is a pretty significant and impressive track record. For example, a 2011 study by a number of economists found that over the prior 40 years, 153 new FDA-approved drugs, vaccine, or new indications for existing drugs were based on fundamental research done by NIH. Likewise, Lowell found that 15% of new drug discoveries were coming from knowledge generated by academic labs, most of that funded by NIH. A study just came out about a month ago, and it looked at the role of the effect of NIH funding on patenting, and it found that for every additional $10 million of NIH funding, there are 2.7 patents that are filed. Another study looked at how much does society get if we collectively allocate $1 more to NIH. How much do we get for that? And the answer was we get 43 cents a year in perpetuity. So think about that, and how many of you would be willing to loan me $1 if I gave you 43 cents every year for the rest of your life? And you would all be coming up here to give me that $1. That's what NIH funding is. Another study by Cockburn and Henderson at MIT, really probably the best academics looking at the impact of NIH funding on biomedical innovation, they concluded, quote, there are a number of econometric studies that, while imperfect and undoubtedly subject to improvement, between them make a quite convincing case for a high rate of return of public science in the life sciences industry. In other words, we get a lot from it. It's not just stuff that goes off and somehow there's some papers that are written. The discoveries that we pay for as a society end up providing real value. And you see that value, for example, directly in terms of healthcare savings. One of the best economists in this, Lichtenberg, did a study where he showed that the social rate of return from pharmaceutical innovation is 67%. In other words, every dollar spent on life sciences innovation generates $1.67 for society. Another study, for example, found that if we could get a 1% reduction in cancer mortality, that would provide $500 billion in net present value benefits, cost savings, and other benefits to society. So I think we've only scratched the surface. It's not like economists sometimes say there are diminishing marginal returns in certain places. I don't think this is one of those spaces. The returns don't appear to be diminishing anytime soon. The scientists will be much better at this than I am. There's so much we don't know. There's so much that can be discovered and then translated into actual therapies that the idea that somehow we wouldn't want to keep doing that. Last point I'll just make is NIH funding is one of the important reasons why the U.S. leads the world in biomedical competitiveness. Between 2001 and 2016, we lost, 28% of U.S. manufacturing jobs. And yet, we gained 22% growth of biopharmaceutical manufacturing jobs. So this is really almost the kind of signal success story in U.S. manufacturing. So if you're working at a biotech company where there's one of bio members and they have 10 people, or you're working at a big pharmaceutical company, it's classified as a manufacturer. You're making something. And it's one of the few sectors where the U.S. still maintains global leadership. We're still growing employment. We're still growing startups. Since 2007, the number of biotech startups have grown 56% in the U.S. And that's all because of this ecosystem, and a core part of that ecosystem is NIH funding. Now, here's the problem. The problem is that while we've been leaving aside the last 2 or 3 years where Congress has come to the table with appropriations increases, we were largely asleep at the switch since 2003, and other countries were not. And so, for example, while if you look at government outlays on health R&D, we were down a percentage point since 2006, essentially 2017 to 2016. Denmark was up almost double. Almost triple, 185%. Korea was up 177%. Germany 65%, Ireland 42%. So country after country around the world, even in countries where they have fiscal problems, like Europe, they are investing, they're pulling out the checkbook to invest in biomedical research because it's such a big, important driver of both health and competitiveness. And we're going to see that more and more. We have a new report coming out soon on looking at China's life sciences strategy. China isn't all that good at it right now, to be clear, but this is a targeted area. So if you look at Made in China 2025, life sciences is a key component of that, and in particular, they're really focusing on biotech, large molecule drugs, as opposed to the small molecule, and they're focusing in particular on genomics, genetics, genetic engineering, CRISPR, and the like, and they're putting an enormous amount of money into this. We shouldn't lose sight of that. For example, Chinese biotech venture funding, which is mostly government funneled somewhere in there. In the first half of 2018, Chinese-backed venture funds invested $5.1 billion into U.S. biotech firms. So they were investing in our firms, $5.1 billion in just the first half of last year in order to gain that competitive advantage. So in conclusion, let me just conclude by saying there are really 3 major justifications for supporting a more robust funding of NIH. And number 1, better medicines and health outcomes for Americans. Number 2, the ecosystem support to enable a vibrant industry. And number 3, cost savings. And we lose sight of that particularly when we're looking at all the budget. But drug innovation does produce cost savings in the long run that is going to make it easier for us to deal with healthcare costs going forward. So with that, I'll stop and turn it over.
Thank you. It's a real pleasure to be here with such a distinguished panel. I haven't really thought much about what I'm going to talk about, except I wanted to give a few examples. So I have been in this country for 25 years. I came for 2 years to do my postdoctoral research and never left. And I came from an environment in England that was rich in developmental biology and embryology. Of course, England is where the first IVF babies came from. And so I came from that sort of environment that was rich in developmental biology, came to the US, moved to New York in '93, the year the Human Genome Project was announced. Very exciting time to be in this country. And without a doubt, thanks to the efforts of Francis Collins and others, the US led the world in the genome era and still continues to do so. We've lagged behind in other areas, and that's because of the relatively lower amount of investment in those areas. So, for example, we mentioned CRISPR just now. We are, without a doubt, poised to make huge advances in genome editing in the next decade. But this all requires, for example, fundamental investment in stem cell research. Now, stem cell research has been a hot topic here for many years, mostly because of the ethical and religious issues surrounding stem cells. But what's happened, because of our limitations in stem cell funding, as an example, other countries have been allowed to soar ahead, Japan, China, European countries, for example, restricting very much the advances in stem cell technology that are essential for taking advantage of CRISPR in the next decade in this country. Scientists have found ways to get around the use of human stem cells through iPS cell technology, but I think that the damage has already been done because we already are lagging somewhat our competitors across the world. And the stigma now is such that stem cell research of any sort is relatively poorly funded compared to other areas. So this is a really good example of an area of research that has been stymied by low funding compared to say, the Genome Initiative, which we led for many decades. So those are sort of, to me, two very, very clear examples of on-the-ground research that needs fundamental investments in terms of basic research for us to move forward. We are poised in the CRISPR era to make huge advances in the ability to take patients with real diseases and cure those diseases on the ground. And this could happen within our lifetimes, but only if we have a continued investment in basic research funding to allow that to happen. In my own research, I've been NIH funded since 2000, I'm very happy to say, and I just had my longest running R1 grant refunded for the 18th year in a row, so that's really happy. But many of my colleagues haven't had the same good fortune, sadly. And what we found over the past 8 years is more and more senior investigators losing their funding after 20, 30, sometimes more years of continual funding. We've also seen a dramatic increase in the age at which new investigators get their first R1 because it's harder and harder to get into the research funding era. And so what we find is that instead of people in their early 30s getting their first NIH funding, they're now approaching 40 and above before they get real funding. And that's a real problem, because what we do along the way through that decade is we lose the best and the brightest minds. And so this doesn't only impact these long-term scientists who've done amazing work for several decades and are now losing funding, but we're losing generations of young scientists because it's just too hard to keep competitive. And so I think there are many reasons to keep the push for NIH-funded research and to bring more people into the fold, because the more people we have, the better minds we'll get, the more competitive we'll become. I've had a good opportunity over the past 10 to 15 years to see research endeavors in Europe, primarily in Germany and in the UK, and they're constantly reinvigorating their science by bringing in young faculty, by teaming up young faculty with senior faculty to bring together collaborative groups of scientists. And I feel that that's somewhere that NIH really is trying to move towards. Collaborative science really is where the future lies. We can't be experts in all these different areas. And so we need genomics people to mix with computational people, to mix with whole animal scientists, with veterinarians, for example, to promote the very best science that we can promote. At Cornell, we have a medical school that's quite distant from the Ithaca campus, and so we've been trying to bridge that gap by promoting the idea of these collaborative program-style grants. And these are a huge investment in time for the researchers, but actually quite a good bang for the buck in terms of NIH funding. And because what they do is they are slightly larger grants than one would normally get for an individual lab, but they promote collaborative science amongst multiple labs. And I really believe that this is where we should take things. You know, investment in the future, investment in more research dollars, but promoting this idea of collaborative science, because I think that once you bring these minds together, then the result is not just additive, it's logarithmic in what we can achieve. And that's evidenced by our advances in CRISPR. We've taken a biology that started in single-cell organisms, and we've been able to extend that into multicellular organisms, and hopefully eventually into human disease applications. And that's because of the wealth of different scientists that come together to participate in this research. So part of our NIH-driven research at Cornell has brought together these big teams, but has also allowed us to bring in people like engineers who we need really for investment in technology development and electronics, computational people to bring in big data mining type of activities. These are all areas that traditionally are not NIH funded, but without those investments, without bringing those people in, we can't realize the potential of what we learn at the bench and apply it and bring it into the sort of entrepreneurial realm. So for example, we have investments at Cornell where we've taken biologists interested in iron metabolism, we've paired them with engineers to come up with ways to measure blood iron levels. You know, anemia is a huge problem across the world, but it's also a problem here in our own country with pregnant women who have low iron levels. But the ability to monitor iron levels is particularly difficult in some rural settings, for example. And so we're teaming with engineers to find ways to bring meaningful diagnostics to these rural areas to improve health, in this case of pregnant women, but then to develop technologies that can take us globally and provide global healthcare and diagnostics to undeveloped countries. So that's just one example of where we're going. In my own research, I work on stem cells and the development of stem cells into germ cells, so eggs and sperm give rise to all of us and to our future offspring. And that area particularly has been woefully underfunded because of the religious and social issues around working with human embryos, for example. But in order to, you know, the flip side of that is what's lost on that is an investment in making healthy babies. And so the National Institute of Child Health and Development, where most of my funding comes from, and most of the funding on embryology and early human development comes from, has been the funding has been very low for many, many years because of the social and religious issues relating to this sort of work. And what's happened is that we have failed to really keep up in good terms with understanding how healthy babies make healthy adults. And so that sort of area needs to be invested in heavily in the future so that we can mitigate the growing problem of early childhood diseases such as obesity, diabetes, all these things that happen early on and will progress with the life of the individual. So those are the sorts of areas that I feel are underfunded and that need heavier investment. I think that the future is very bright because, as was said earlier, we all agree that NIH deserves funding and deserves robust funding, but what I would encourage is that we start to think of these areas that are relatively less well-funded, such as child health, stem cell research and so forth, so that we can really keep up with our goals of making healthy individuals, but also keep up with our competitors across the world and really lead in those areas that we haven't necessarily traditionally led in.
Okay, thank you.
Hi, good afternoon, everyone. My name is Lily Portier. I'm the Director of Strategic Alliances at NCATS, which stands for the National Center for Advancing Translational Sciences. It is the newest institute at the NIH. We were created in 2011, and our mission is to look at bottlenecks that happen along the drug development, device development pathway on the preclinical end, as well as the clinical end, and I'll explain a little bit about some of the initiatives that we have going on in those areas. NCATS is a disease-agnostic institute, so as you know, some parts of NIH focus on various parts of the body or certain kinds of diseases. We're disease-agnostic, so again, the idea is that we're looking at certain pain points that happen along the translational research process and seeing what we can do to fix that. We also do a lot of collaborations. Our internal R&D group is quite busy with collaborations. We look to collaborate with folks that are disease experts. We also have a great focus on rare and neglected diseases in our organization as well too. My office is the office that pretty much facilitates all those collaborations. So it has the technology transfer functions, which is all the transactional agreements that we put in place to get these collaborations done, licensing of technologies that we develop or co-develop with others. We also do some alliance management, some long-standing partnerships that we have with nonprofit, for-profit organizations, patient organizations, and we manage that. And the other thing that our office does is also manage the Small Business Innovation Research Program, SBIR, and Small Business Tech Transfer Research Program, which at the NIH, this program is now over $1 billion that goes towards early stage seed funding for life science companies across the United States. And it's many of these ideas and new technologies are coming from small businesses, and the SBIR and STTR program is a great way of getting those technologies that are initially created, perhaps with R01 funding, and then the investigator, an entrepreneurial investigator, wishes to find a way to commercialize that technology. The SBIR, STTR program, real focus is on trying to get these ideas into the commercialization stream and to have someone else take them on, or for the small business to further develop them. And specifically with that program, at the NIH, we have a lot of supports for academic entrepreneurs who want to take their ideas and try to commercialize them by having some supporting programs along the lines of how to put business development plans together to try to attract additional funding and leverage what the NIH has provided in terms of the SBIR grant. And we also started a couple of years ago a program that we've adopted from the National Science Foundation called Innovation Corps, ICOR, which teaches investigators how to do customer discovery. Basically, is my technology really going to address a need that is out in the community? Who are my customers? Understanding what the regulatory pathway is for a technology, what the insurance reimbursement pathway is. And these are all things that academic investigators, while they know much about the science, it's not an exposure that they have in medical school on how to put a business together or things that they would need to know in terms of forming a company. So if you get funding through this program at the NIH, there are some additional resources that we can provide academic investigators as well as small businesses in the life sciences, some additional supports to help them again, translate these early stage ideas into hopefully what becomes a commercial product, which eventually is an patient intervention and it addresses some kind of therapeutic need out for patients. The other thing that NCATS does, I'll talk about a few programs that we have and how we deal with this translational process as well too, is we have a couple of de-risking programs. These are programs that For instance, an investigator who has NIH funding is developing a drug and gets stuck because they need additional funding to get it to perhaps an IND filing to the FDA. So what happens is that the investigator has all this data, they go to the FDA for a meeting, and they find out that they need a very important tox study, an animal tox study that they don't have the expertise to run themselves nor the funding. But they can come to us through a couple of these programs called the Therapeutic for Rare and Neglected Diseases program, as well as the Bridges program, where we will provide them access to contract research organizations that we have, help them run the study, provide them the data that they can then go to the FDA and file this IND that they may need for a new patient intervention. And I'll give you an example of an investigator who had NIH funding through R01s and an SBIR for developing a new drug for a rare disease. And she went to the FDA for her first meeting and wanted to show kind of her data package because she was interested in filing this investigational new drug application. And what she heard from the FDA was, listen, you know, you've got great data here, but we need you to run these animal studies on animal studies in order for us to successfully file this IND. And she was basically stuck in what we call the valley of death, right? Because her institution did not have the funding for it. She didn't have the proper expertise to run the studies herself, so she came to us and we helped facilitate that, give her the data. She was able to successfully file this IND for this new drug. As a result of that, she was able to attract venture capital funding, around $60 million Series A funding after filing that IND. So these programs are resources that help patients, help these patient interventions kind of move through their pipeline and address these bottlenecks that happen around the development of drugs. Another program that we have is the tissue chip program. And the tissue chip program is a program that we are trying to mimic through these chips about this size of different human systems. So for instance, a lung on a chip or a kidney on a chip. And the idea here is to test drugs early on to see if there's any toxicity to these human systems that are on these chips. And the idea is that this will help facilitate getting a drug quicker to patients because you're able to assess whether there's effects on, for instance, on the lung or something like that. But not using animal studies because they take longer and are more costly to do so. The idea would be to look at this as a way of trying to address those bottlenecks that I was telling you about. We also have the Office of Rare Disease Research that helps patient groups put registry together for their rare diseases and holds every year a Rare Disease Day, and patient groups get together to talk about how to address rare diseases that happen. Many of these are parents of children that have rare diseases, and talk about the journey of difficulty in diagnosing rare diseases and how to eventually find treatments for what is over 6,000 or so rare diseases that exist right now. So NCATS does many things, and again, my office is there to facilitate these collaborations that we have with industry, patient groups, small businesses, and we're a very busy group, and we think collaboration with the outside is the only way to get these great ideas out and hopefully into patient interventions and addressing some public health need. So I will stop there. Thank you very much.
Just set this timer to give you the false sense of security. I'm going to be short. My name is Sudip Parikh, and I have the privilege of leading TIA's activities in the Americas. You wonder what that means. TIA is an organization that represents all the folks who work in drug development inside the companies, inside the FDA, inside of global regulators, whether that be FDA's counterparts around the world, and also the companies around the world. And so we're really the folks who catch what comes out of NIH. So if you think about it, we live in extraordinarily exciting times. And so I'm going to tell you two things. I'm going to tell you, one, about how these exciting times are a lagging indicator of our investment in NIH. And the second thing I'm going to tell you is about how other countries have figured this out and what they're doing about it, and sort of a story about why we should be preparing for that. So first of all, this idea of a lagging indicator. These are incredibly exciting times. There are advances happening on two fronts. One is on the life sciences side. And that is the things that we just heard about, right? It's gene therapy, it's gene editing, it's CRISPR, it's immunotherapy, it's all the words that you've heard about companies that are in the pathway to getting drugs to patients that have a real opportunity for extraordinary change. We talked about cures today. We talked about turning deadly diseases into chronic diseases, and there are examples out there. So, for example, the first CRISPR technologies are making their way into the clinic. The first patients have been treated with therapies for sickle cell in the United States, coming out of CRISPR Therapeutics. You see the first clinical trials for beta thalassemia happening in Europe with these gene editing technologies. You see a cure for night blindness out of a company in Philadelphia. You see the opportunity for children that used to die at age 15 from cystic fibrosis living lives where they have children, where they may have grandchildren. This is extraordinary. It's never happened before. These are people that if they'd been born 10 years earlier would not have lived. And so these are extraordinary exciting times on the life science side. And then you pair that with what's happening on the information technology side. So we talk about big data and artificial intelligence and blockchain, and who knows what all that stuff is. I couldn't tell you. But what I can tell you is that they are being talked about at every stage of the drug development pathway. So we're talking about the idea of using real-world evidence to expand labels for drugs for conditions that they weren't originally thought to be useful for. This is an extraordinary opportunity to repurpose old drugs using data. We have the opportunity to do personalized medicine, and we can only do that because we have these advances in the information technology side. And so when you pair those two things together, we're looking at extraordinary times with the real opportunity to cure disease. The problem is that's a lagging indicator. Those are based on investments that were made in the past. Okay, so the latest of those things, CRISPR gene editing, the seminal papers were in 2012. I can be wrong about that. The experts are sitting here. But in that space, it's 7 years ago. But to be honest, the actual discoveries were in the 1980s. Isn't that extraordinary? So by 1987, somebody had seen these first repeats inside of bacteria that are related to CRISPR technology. So those investments are lagging. And we have to make sure that we continue to fill that pipeline so that the people that I work with on a daily basis have the next thing to worry about. They want to worry about how do you get some of these new technologies through the regulatory pathway. They want to face those challenges. They want to have the opportunity to think of a new way to get a digital health technology through the regulatory pathway because it's been discovered by someone in the scientific lab at NIH or at the university. So that's the first thing. These are lagging indicators, and we stand on the shoulders of people that appropriated this money 15 years ago. We got to keep doing it. The second thing is I want to talk about the sort of global nature of this today. And to start, I'll tell you a story. This room has lots of memories for me. On October 8th of 2001, I know exactly where I was. I was in this room. And the reason I was here is because the day before, somebody in the Hart Building opened up an envelope with anthrax. And the extraordinary thing was they closed the building that day. Okay, so anthrax envelope opened. They closed this building that day. The next day, they called all of us back in here, into this building, to come into this room so they could do a swab test on us, which is an epidemiological test. I didn't really tell you that you've been exposed to anthrax. It's an epidemiological test. But that's what they did. You know why? Because we weren't really prepared for something like that, right? We hadn't thought through what would you do if a building was exposed to anthrax. And so people of goodwill and good intention made mistakes. They made the wrong decisions about what to do. Because then we ended up exposing 4,000 people to anthrax that would never have been exposed because they had left the building immediately. And so that's the result of not being prepared, not seeing the threat coming. Well, this is the threat of other countries, other nations investing in biomedical research and copying the amazing ecosystem that we've created here is not something that we can't anticipate. It's something that we've seen for a long time coming. The rate of growth of investment in biomedical research by China and other countries has been growing for some time. We could predict even 10 years ago, if you just sort of made it linear, that China was going to be ahead of us in terms of biomedical research investment on purchase price parity actually by this year. And they basically are. They're about 80% at nominal rates, and with purchase price parity, probably pretty darn close. Now, you're right, so they're not great at it yet, but they will be. And so we have to make sure that we're looking at those threats, we're looking at that competitive factor and being ready for it. Because what we don't want to do is end up calling everybody back into this room to be exposed to anthrax. We don't want to end up saying, yeah, we saw that coming, we didn't really do anything about it. We didn't get prepared, we didn't make the investments that were necessary. And yes, now we are either at parity or worse. We are no longer the preeminent place where that ecosystem thrives. And that ecosystem thrives because we have investments in people and infrastructure. And that is extraordinary work that the NIH does, and only the NIH does in the United States. Stop that there.
Great, thank you. Okay.
Good afternoon. As mentioned, I'm Danielle Friend. I'm the Director of Science and Regulatory Affairs at the Biotechnology Innovation Organization. BIO is a trade association that was founded in 1993. We represent approximately 1,000 biotechnology companies that work in the industrial, environmental space, agriculture space, and the health space. The large majority of the companies that we represent, however, fall within the category of health. So I think about 90% of our biotechnology companies are within that health sector. The other thing that I want to mention is that a lot of the companies that we represent are very small. About 90% of the companies that we represent don't have very much revenue at all, and that's because they don't have a product yet on the market. They're in the very early stages of bringing their products to the market. I'm particularly excited to talk to you today about investment in science and biotech and NIH in particular. I'm sure I'll highlight this through my talk, but my undergrad research was funded by the NIH, my graduate research was funded by the NIH, my postdoctoral research was funded by the NIH, and my AAA scholarship was also funded by the NIH. But I think, a couple of the things that were highlighted through the talk today, through the speakers today, is that the outcomes from the NIH really make a large impact on health outcomes. In particular, spurs economic competitiveness, adds years to lives of individuals who maybe would have not been able to contribute to the economy due to their health conditions. But also, as I mentioned, creates jobs, trained scientists, and I would say a highly skilled workforce. But again, I think the NIH, in partnership with industry, they really have unique aspects to play in this U.S. competitiveness. When you take a look at the drug development life cycle, there are several phases. So it starts with basic research, where investigators might be taking a look to see, what symptoms are associated with a particular disease, maybe what some of the underlying mechanisms are in that specific disease. And then once you move on to basic research, you're then looking at discovery. So in that phase, you're taking a look and saying, can we develop molecules that target that specific pathway that we think underlies that disease? Moving on from basic discovery, you move into preclinical research, and oftentimes what you do there is you test molecules in perhaps animal models to see if your molecule is actually targeting that pathway and actually making an impact on a disease. And then from there you move into clinical trials, which generally have about 3 phases. But again, that's where you're testing that molecule in the patient populations to test safety and efficacy. And then from there, of course, one would apply for FDA approval, and there may be post-marketing studies following that. But I think that is, really where there's a connection between the work that the NIH does and the work that industry does in spurring economic competitiveness. So that basic research, so things like identifying biomarkers involved in a disease, or maybe that help diagnose a specific disease. some of those symptoms that are associated with the disease, the mechanisms that underlie those diseases, that's really where NIH is very strong. And I also want to emphasize that there is research that NIH does that doesn't obviously have a disease impact at first glance. And because everyone on the panel has mentioned CRISPR, I will also. CRISPR is a good example. Investigators started studying CRISPR not because it necessarily had a disease impact, but as was mentioned, we're now thinking about how we can use CRISPR to develop therapies for the patients that need them. I also want to highlight that there are several activities within the NIH that really spur economic competitiveness, especially for small companies, and that is the small business grants. Those programs, I'm always excited to hear, we get emails from some of our very small companies when they are awarded a grant, and they're always very excited. We're happy to see that. And then the other thing I want to mention is the public-private partnerships. So things like the HEAL initiative, helping to end addiction long-term. That is an area where industry is working very closely with the NIH to hopefully identify novel and safer pain and addiction therapies moving forward to mitigate the current crisis. But as you all know, drug development is extremely difficult. The success rates for therapies are very low. I think it's about 10% once a therapy enters phase 1 for it to kind of continue and go through the FDA approval process. It's very costly, so it's estimated that it costs about $1.5 billion to bring a therapy to the market. And that really takes, again, a collaboration between NIH and industry in order to accomplish that basic research, bring that all the way through the drug development life cycle, drug discovery, preclinical research, all the way to the clinical research as well. And so I think that's where you really see, again, once the country makes the effort and makes the commitment to invest in the NIH, I think that's where it really gets biotech excited. You see where the NIH is putting, or the federal government is putting forward money that really gets us excited, about areas to follow and invest in as well. So, for example, in 2017, the NIH budget was around $31 billion, but private industry contributed another $165 billion to those efforts. Again, because the process is lengthy and expensive, and they see, they see the positive outcomes, and they see the investment that the country is making. And so, just to highlight, because I think a lot of the panelists have covered some of the thoughts that I want to put forward, but again, I think investment into science and biotech benefits the U.S. economy. Again, improving health outcomes, creating jobs. And there's a strong partnership between NIH and industry in order to make sure that those therapies are brought to patients and taken through the drug development process. But each entity, the NIH and industry, I think has very unique roles, and it's really their collaboration, which I think has been highlighted, that spurs that economic success.
Great, thank you. So, I want to open it up for comments and questions from the audience. Before I do that, I want to ask all the panelists, if there are any of you who want to jump in on this. One of the things I think that a number of you referred to or alluded to is that there's an ecosystem with some kind of division of labor. And yet when you sort of get out of the industry/academic space, you get into this kind of Manichaean world where some people on the right say, why have NIH? And you get all these big biotech companies in Georgia. They can do it all. They got labs. And then you have other people, sometimes on the left, that say, well, why do we need these drug companies that just triple the NIH budget and you guys can develop all the drugs and then we don't have to worry about it. To me, this is the fact that there's an ecosystem and a division of labor. So I don't know who wants to sort of jump in on that. How do you see that playing out?
Well, I can start. I don't have so much experience with industry and industry partnerships, but what I will say is this. So on the drug development front, that's a huge investment of money, and it's something that would be hard pressed for a federal agency to support. So it's clear that we need industry investment there. On the research, the basic fundamental research side, I was speaking to some staffers this morning about CRISPR, and made the comment that China isn't doing their basic research very well. there's this big fear about the CRISPR babies in China and how we could do things better. Well, there's nothing better, to my mind, in terms of the integrity of science than having it go through an NIH process. So the very fact is sort of the ultimate in peer review, the very fact that basic research is critically assessed and evaluated and then scored through an NIH funding mechanism, through a study section, through the ethical lens of NIH with all of the various factions involved in it, makes the science better, keeps us as basic researchers honest, if you like, and maintains a fundamental level of ethical standard that we want to adhere to. Yes, scientists come to the table to make it, to have an opinion on that, but we shouldn't be the only people. And so I think NIH funding is the start for everything. And then when you get to drug development, you need that investment from the outside world, and that's how I see the partnership. And without those two aspects, I don't think our entrepreneurial goals will be met.
And I want to just echo what you're saying, that the peer review process is very much something that especially a small business can leverage for additional funding, because basically your science is validated by NIH. And we know that many of our grantees that go through the process and score well are then able to use just the fact that they scored well as a way of attracting additional funding to their companies. And this idea, I want to also speak to, NIH is not poised to put a drug in the market. We have to work, especially with the internal R&D, the intramural program, we have to work with industry in order to move our ideas into patient interventions, because we cannot do that process. So we have to collaborate with industry, small businesses, in order to move those ideas, hopefully to make a patient's life better. So I just wanted to make sure that I said that. Yeah.
Good.
The only other thing that I would add, and I think some of us have highlighted, is that we don't always know what scientific advances will lead to a therapy, per se. And I think that there is a strong need for funding for the NIH to explore those things. We don't always know what will develop into a therapy, and there are many circumstances where scientific advances impacted something many years down the road in an area that we would not have expected at all. And I think that can be a little bit more difficult for a company to tackle.
Okay. Turn it over to you all. Comments or questions? If you have any, just raise your hand and wait for the mic. Lady in the back there.
I don't know if I need a mic. So in the report, Dr. Atkinson, you did a really interesting job of explaining some of the investment in China and the policies. Can you kind of, give us a little bit more granularity on that, and then any ideas or recommendations you have for the U.S. context? I thought this was the most depth that I've seen about some of the intricate policies that China's putting into place in a while.
Yeah, I have to say there's a little bit in this report, and it's based on some forthcoming work that I'm probably about halfway through, so there's still more for me to learn there. One of the things that China's doing, besides the fact that they're dramatically improving their drug approval process, the equivalent of their FDA, which is kind of shoddy for a long time, they've really ramped that up, and they're trying to get rid of, frankly, there's a lot of drug producers in China that are very small. You don't know what you're getting. So China's in the process of having a very big restructuring of their biopharmaceutical industry to weed out a lot of small, bad firms, if you will, and really concentrate on I won't say national champions, but on a much smaller share of firms that can gain global market share. So part of that is around some government funding. Mostly you see that at the provincial level, where provincial governments they're more important than state governments in the U.S. in the sense they have a lot more fiscal ability. And so a lot of provincial governments are funding biotech and biopharmaceutical companies in their region. So for example, in some of these places they have, in Beijing, for example, there's this biotech park, research park, And it basically, I don't have it here yet. No, sorry, Shanghai Pharma Valley, 10 square kilometer life sciences hub, home to 500 biotech companies. The Chinese Ministry of Science and Technology, MOST, is committed to building 20 new bioscience parks in the country by 2020. These aren't just like, oh, you get some cheap space. If you get cheap space, most modern space, you get other grants, you get all this other assistance. So it's a big way that they're supporting their startup ecosystem. I mean, here it's much more happenstance. If you happen to be in Philly or San Diego or something, maybe there's a local program that's providing some kind of help, you're lucky. But the Chinese are just, I mean, Chinese, if anything, they're incredibly systematic. And then I mentioned venture funding. The Chinese are pouring an enormous amount of money into this. Some of it's real venture in the sense of private sector, but most of it's government-supported venture. And they're just trying to go and find all these different innovators. And a lot of it is, so for example, another one, if you look at this, is Beijing Genomics Institute, or BGI. At one point, BGI accounted for a quarter of all DNA sequencing machines in the world, one institute, and this was all government funding. So, they're willing to put make big bets. For example, they just devoted $9.2 billion to the Precision Medicine Initiative. Now let's compare that to, which by the way, their Precision Medicine Initiative seeks to map 100 million human genomes. So compare that to the Obama initiative, which we liked, but it was a $215 million targeting of 1 million patients. So they were essentially, 40 times more in terms of money, and 100 times more in terms of patients. So, they aren't playing around. I mean, they're just, they got all this money, they're just going to make these huge bets, and if half of it pays off, they'll be super happy. I mean, they don't really care whether stuff doesn't work. It's just throw it at the wall, see if it sticks. So it's hard to, as I said, I'm not by saying that they aren't good scientists. I'm just saying overall, on net, their companies aren't as good as our companies, and their researchers, they don't have as many good researchers as we have. But they're really working on that. Another program they have is the 1,000 Talents program, where they're actively recruiting. In fact, that was actually a question I wanted to ask all of you, whether any of you are familiar with this. They're actively recruiting both people who get their PhDs here in life sciences, but also I've heard actual professors, scientists here back to Beijing with this offer of, you come back here, you're going to have this lab decked out, with the best equipment and a huge budget for 10 years and a big team. Hard for us to match that sometimes. We can match it through things like, well, you give more creativity and flexibility here, which is important, but I don't know if anybody has any experience in seeing that.
It's spent a lot of time in China. Over half of our numbers are outside the United States. About a third of them are in China, and that's the fastest growing area for membership in DIA, which again are the people who are doing drug development and regulating drugs. Yes, China has recently reorganized their FDA. It's called the CNDA. It's extraordinary. There are probably 20 senior FDA officials who have been recruited to work in the CNDA. So they're former FDA staff who are working at the CNDA. Reorganization, a lot of the guidances look a lot like the US. It's amazing how quickly you can pass guidances when there's not a comment period. And so there's a lot that's going on there. In addition to that, on the research side, I'd be careful. If you look at the number of papers that are published and the citation indexes, if you look at Chinese researchers, that plot is changing rapidly in terms of what you see between the United States and China and Europe. And the other piece of the nugget of information I can give you is that about 3 years ago, when I first joined the DIA, I went to our meeting in China, which has about 3,000 people. Of that, the vast majority at that time were employees of large multinational drug companies, right? So Pfizer, Merck, and AstraZeneca. This year, over half are working for Chinese firms. And the reason why is because they see the opportunity to have there are at least half a dozen companies with PD-1 inhibitors that are going through the regulatory process in China right now. There are CAR-T therapies that are making their way through the Chinese regulatory authority by Chinese-owned companies. And there are CRISPR companies in China, in Shanghai. So what I'd say is the pace of change is so rapid in what's going on right now in Shanghai and Guangzhou and Beijing that if you read something from 2 years ago, it ain't right. You need to go and look and see. The CNDA formed 6 months ago. The pace of change is remarkable. And the last thing I'd say on this is that there's a very, very explicit goal, which is to create not just national champions, but global champions, their own Pfizers and their own Mercks. And look, it's hard, right? 5-year plans have a notorious history of failing. But plan beats no plan a lot of times. So I think it's important to make sure that we're keeping an eye on it.
Anyone else on that? Okay. By the way, just a quick comment on that. There's a report we also released on Monday, if you're interested in digging down on that. It was a look at about 30 different indicators of where China was relative to U.S. on 30 different innovation indicators from 2006 to 2016 or 17. And to your point, you just see rapid progress. Most of them are still a little behind us, but it's just going up. So, yes, right here.
Hi, yes, I'm Ruth Bowman. I'm Dean of the Milken Institute School of Public Health at George Washington University. And I'm really struck by your second figure. And two things. I mean, one, that if just every year research had grown 3% per year funded by NIH, we'd have more research today than we do after the doubling, which is rather shocking, but it's easy to see how that can happen. And that in the context, of course, the health care costs in this country have gone up by far more than 3% a year over that time period. And that our investment in biomedical science is in no way keeping pace with the costs to society of our chronic, especially health problems. I don't think that the U.S. public understands that. I mean, I would be one of the last to say that it's bad for people in China or anywhere else in the world to be doing biomedical science and innovation. I think we've worked to expand that capacity for research and development, and it's a good thing for everybody in the world to be working on these problems. But it's appalling to see that we are spending more and more and more into the pipe for treatment, and that we are not putting commensurate resources into fundamental research, research that leads to prevention that leads to cures. And that is rather, I think it's a message that hasn't come across. I mean, the other thing I see with the graph, and we in academia are aware of this, there was a time when the rate of increase went up very fast, when there was the doubling. And that was a time when it felt like it was a little bit difficult to keep up with that, and then afterwards you can see the cliff that occurred. And I think people are afraid of that, and that we have to start speaking more honestly about what's been happening, that we really have left behind in terms of addressing the magnitude of the policy expenditures that we have in this country. Thank you very much. The report has so much valuable information. We really appreciate it.
Anyone want to comment on that? Okay. Yeah, I mean, that's one of the, I couldn't agree with you more about this. There's I don't say an illusion and a delusion out there that somehow that drug innovation is going to cause healthcare costs to go up. And in fact, when you really look at the evidence, it's the opposite. You look at diseases like diabetes, Alzheimer's, you all know this better than I do. I mean, these are going to be huge, huge costs to society if we can't crack the code on some kind of treatment. And that's not going to come from magic. I agree with you on China, by the way. I mean, at one level, we want China, and if China can solve Alzheimer's, that's great. I'd rather we do it, because then we get two benefits, because we solve Alzheimer's. Alzheimer's gets solved, and we create or help companies that are going to be, global leaders in that, creating all the good jobs and tax revenues that come from that. But I agree. At one level, it's not a zero-sum game. Other countries are investing and the science is advancing globally, as you know. So.
bipartisan consensus. You mentioned, Rob, that Congress supported NIH funding. The President's budget proposes a 12% cut in NIH funding, which according to CQ is one of the largest cuts of any federal agency in this budget. Just curious what you think the impact that a cut of that magnitude would have on our ability to innovate, compete, fund basic science and basic research in places like Cornell.
Well, the great thing about our system is that the Senate decides these issues, and not the President. The President's budget cuts R&D, and particularly NIH, but also NSF, and it's frankly a disaster. It's short-sighted, it's ideological, and I think it would have two big problems. Number one, I think to your point, if you're maybe 30 years old right now and you're thinking this is going to be my career, and you see that kind of cut, you basically can say, well, the odds of me getting a grant by the time I'm 45 are a lot lower, and maybe I'm going to go over into industry, or maybe I'm going to go into some other field, or maybe I'm not even going to enter this field if I'm a BS degree. I'm going to get a master's in something else. So I think that number one, it sends a really damaging signal to the future crop of people who need to be doing this work. The second thing is, and to your point about this graph we have on figure 2 on page 8, where you see this spike and then it goes down. Well, that period of going down is not a happy period. Now, it would have been a lot better if Congress had just stayed on that line. You know, up. Then you send a clear signal to the marketplace, if you will, the marketplace being researchers and students, that you can predict what's going to happen. You can then absorb that funding so that you're funding really good work and it expands organically. And I think that's, Congress has been doing that, and you see that in the graph. But I think Congress needs send a bipartisan message that says, yeah, we're going to try to get back up to that point. But then, look, we're going to do this for 20 years. We're going to try to increase 2-3% a year above inflation for 20 years. And sending that signal, now obviously Congress, they don't do budgets for 20 years, and Congress, you can't constrain the future Congress, I get all that. But it's just an important signal to send. And, it's disappointing that the President, when he talks so much about U.S. manufacturing, U.S. competitiveness, that his team, and Mulvaney in particular, they don't understand the importance of this. Other thoughts?
Yeah, I'll add to that. A lot of the damage has been done with this current generation of postdocs. I ask my postdocs if they're going to go do what I do, take my job. And they're like, no way, we don't want to do what you do. They're really, really scared. I mean, we have a real deficit coming where we're going to lose a generation of scientists not too far in the future. If you poll graduate students now, most of them will, it used to be when I first started my lab, we would have these alternative career days for our graduate students. And they really were alternative. They were the kooky people who went and did what these guys do, and did policy making and just the weird people. And now that's the majority. That's the majority of our graduate students do not want to do my job. And your guys' taxes pay for me to do the best job on the planet. And I love what I do, but I can't say that I blame them when there's this struggle. Whereas we do get a healthy crop of Chinese graduate students who are all outstanding, and they're all coming over to graduate school here with the promise of being lured back to China, where they do have the incentivization, they do have this wealth of resources, and so we are going to find ourselves not just lacking for money, but lacking for talent, and that's a really significant problem, because our best and our brightest are not going to stay in environmental research in the near future.
Yeah, I'd like to address one other part of that question. So, people always say, it's the President's budget doesn't matter. It's Congress is going to decide. Here's one thing that we want to think about in terms of it mattering, and that is that when the President's budget proposes something, it's there's a force to it. So, for example, the Precision Medicine Initiative or the Brain Initiative. These are ideas that come out of leadership from the executive branch to drive a part of the research, right? So when Francis Collins or Tony Fauci or Gary Gibbons or whoever it is at NIH has an idea about something that needs to happen that is for the collective good of the nation, they can put that in the president's budget, and it becomes a part of our policy, it becomes a part of the momentum that we build over time. So when you propose a budget that cuts the NIH budget by 12%, is there a precision medicine initiative in there? Is there a brain initiative in there? Is there a CRISPR initiative in there? There is not. There is not leadership from the executive branch to actually drive the research forward. And so yes, we have the dollars, and yes, I'm confident NIH will do great things with it, but it doesn't create the process for leadership that's required when you're running a $40 billion agency and a $3 trillion government.
One of the other disconcerting things about the president's budget bill is President, part of his team in the White House has been advocating for an national AI strategy. We've been working and helping them on that. We have a new report coming out fairly soon looking at the role of AI in drug discovery. I think a couple people mentioned that now it's you mentioned that it's a combination of you got to bring the engineers together and the veterinarians and the biologists. You also increasingly need to bring the data scientists together. Well, NIH is going to fund some of that. And without the NIH budget were to go down, which I don't believe it will, and I pray it won't, we're not going to be in the lead in AI-based drug discovery. And that discovery, by the way, if anybody's read Eric Topol's new book, nobody's read Eric Topol's new book?
Yeah.
Deep Medicine?
Yep.
Really worth reading. A review on it coming up shortly, but it's an excellent book. And Topol is, I believe he's an MD and researcher at Scripps. And it's a pretty amazing book about how AI is going to improve healthcare and healthcare discovery. And so to me, it goes back to this point about, it'd be like, this is the worst time to do this. Like, oh, this is the time when all this cool stuff is coming together, and we're like, ready to go. We are going, but we're ready to go even faster. So that's another part of the reason why. One thing to sort of cut it when nothing was, when the industry is mature, if you will. All right, it's kind of mature. It doesn't seem like there's much we can do, but that's not the industry at all now. The industry is anything but mature. It's dematuring. There's more and more way opening up of discovery routes now. So.
Just to build on that as well, obviously AI is a hot topic for a lot of our member companies as well, but kind of connecting this to the training aspect as well. If you don't invest in this now and train scientists to do the data science, to learn how to work with algorithms, we won't have the scientists to push it further down the road as well.
And I'd like to add that it's those new innovative things that happen that create new ecosystems, right? And we experienced that when we put the tissue chip program together. We've created a little ecosystem of companies that are now coming to us saying, I think we can solve this problem too. I think that's very powerful.
Great. Other questions or comments? So I have one. Excuse me. I have one, and that's we've alluded this a little bit about the talent issue. There are stories that you read, and I just can't, I've never seen enough data to say how much of a problem it is, but the foreign countries recruiting our scientists and more and more our scientists, but then also recruiting our graduates to come back home, whereas 20 or even 10 years ago, we could have counted on them staying here and building their careers. Do you see some of your students kind of thinking more of especially your foreign students thinking, the opportunities might be a little better in the home country than they were before?
Yeah, even worse than that, I've had, luckily had a lot of success. So are you all familiar with K99 awards? These are these career development awards from NIH. They're a fabulous tool for, A, keeping postdoctoral researchers in academic research, and B, kickstarting their careers. And luckily, I think 6 for 6, my lab has had a tremendous success with them. 3 of those recipients of those K awards have gone back to Europe. And I just think that even the promise of early career funding for their own labs wasn't enough to keep them here. And I think because the nature of research beyond their care awards is too difficult. So it's been really hard, and you know, I keep saying that NIH is going to cut me off because I can't keep these guys here in this country. But it's a real shame. I mean, it's I think that we bring these people over, and I'm talking about postdocs and graduate students, and that's just the nature of how we do things at Cornell. We don't have the pipeline for foreign graduate students that I had at my former institution, but it's the same with postdocs. These guys are coming over and they bring such expertise and they learn so much here, and then they go back where there's a better quality of life for them. Even though funding in Europe is declining too, it's still, you know, there are places like Denmark that are doing fabulously well. The European Research Commission is doing really well, the ERC grants. So there's a lot of really strong funding sources over there, despite overall across Europe it's declining.
Well, I think that, I mean, there's a chart we have here, taken two. It looks at government outlays for health R&D, and you know, Germany's up 65%, the UK 55%, Ireland 42%, Belgium 32%. There are some countries like Italy and Spain, some others that because of the budget crisis that have been cut. But you know, if you're in Denmark and you triple your R&D budget or your research budget, it's going to look pretty attractive.
Yeah, Denmark has done extraordinarily well attracting scientists from everywhere. So it's really brilliant.
You know, but I guess the flip to that is that you have these collaborators, right? I mean, and you're able to, you know, work with somebody in your lab that you've worked with with other resources and that they have. So that also makes for a rich research environment as well, right? So it's my way of making, you know, lemonade out of lemons.
I can't speak to students, but I can speak to folks who are in the industry. The head of research for one of the large multinationals in China left that large multinational to start his own company, and I can tell you that they took a large group of people with him from that multinational. So one of the things that I have noted about Shanghai versus, say, Tokyo, you know, in the 80s, people thought that Japan would be the number one economy. The U.S. was losing ground to Japan. One of the things you noticed about Japan, I still have a hard time. When I go to Tokyo, I can't get around because they're not made for foreigners. It's challenging. When you go to Shanghai, you see expat Americans, you see expat Europeans in laboratories. That's something you don't see in other Asian countries, and it's really remarkable. And so I think there is a real call to folks, both as sea turtles, as they call them, to go back, or even non-sea turtles, but folks who were born here but see an opportunity because they want to pursue the science that they want to pursue. They want to pursue it with the incredibly the intellectual freedom that you think we have, but that is also necessitates resources. Intellectual freedom is not free.
Yeah, you're free to do something, but you can't do it because you can't afford to do it. Yeah. That's not really freedom. Okay, any last questions? All right, so I'm going to ask one quick question for each of the panelists. Feel free to not answer if you don't want to, but one of the things that we've written about and we've seen in the last 4, 5, 6 years is that the rate of new drug approvals is going up. So there was a period there where it was going down, people getting pretty discouraged. And I think it was really partly because a lot of the low-hanging fruit had been picked. Hadn't quite figured out all this new stuff. It's really much harder, but now it seems like we are. Drug approvals are going up. What do you, each of us go down the line, in 5 years, what if you're out there, if you're talking to somebody out here and works for a member of Congress, what should they be excited about in 5 years that maybe isn't here right now?
Well, I really hope precision medicine is going to take off in a rapid way. I don't know if this will be in the drug market by then, but I think that we'll be a long way ahead of knowing where we need to go to. The problem with precision medicine is it takes a lot of money. It takes a lot of computational power. At Cornell, we call this radical collaboration. It takes a lot of radical collaboration, people from different areas, different expertise, areas to come together. And without NIH funding that and being the sort of fount of wisdom for that, I don't know if that would happen. But I hope that precision medicine is well fit for this, because then we can really address the current health issues.
Great.
I would say around rare diseases, maybe perhaps initiatives that we're doing around using gene therapy to address a host of rare diseases, and figuring out ways of getting the vector development done more efficiently and sharing that information more publicly. So I think there will be some headway that's being made in rare diseases.
I think I spoke about some of these, but allogeneic CAR T, right? CAR T that doesn't require the precision, that's rather off the shelf, would be extraordinary. These gene editing technologies that are making their way through beta thalassemia and sickle cell, I'd love to see them on the market within 5 years. CF, gosh, that's this close. That's this close to being there. Advances on SMA, spinal muscular atrophy, Duchenne muscular dystrophy. When I worked in Congress, people were, there was nothing, no treatment, no anything. And today we're, again, this close to actually seeing children that lost muscular ability in their spine, so they couldn't walk, to be cured. Again, we're this close to that. And these things are all possible because of, again, the lagging stuff. So what I'm really interested is, what's the 35-year-old researcher working on today in the laboratory that I don't know about? Because that's what's going to feed that pipeline 5 to 10 years.
Sure, I think a couple of people covered this already, but advances in precision medicine, definitely. The topic of gene therapies and the ability to administer a therapy once or maybe just a couple of times in someone's lifetime to address their disease. And then the last thing I'll say is I'm very hopeful that we will have made significant advances on Alzheimer's. I know we continue to see only bad news in that space, but I would say that we're hitting hard both on the basic science level, but also within the clinic. And so I'm trying to be optimistic about advances we'll make in that space as well.
If we just follow up on that, and that's a great example because it's a place where we're not even sure the basic biology at the moment, right? We're not sure that the amyloid hypothesis is the right one to be targeted. Yet we spend hundreds of millions of dollars chasing therapies in that space. NIH is the place where it's going to come from. Right, that's where the next idea about what causes Alzheimer's and the next target for a therapy is going to come from. It's not going to come from the development side that happens in the industry.
Yeah, so let me just close by sort of summing up that point, which is the future seemed pretty exciting and optimistic and a lot more hopeful for a whole set of people who in the past that really had very little hope. But, I could make my life better right now if we just eliminated NIH and we moved totally to generics. My life would be better. I would save money. My taxes would be a little bit lower. I wouldn't have to pay, I only pay like $2 for the drug, right? But why don't we want to do that? And the reason we don't want to do that is because we don't just care about ourselves. We care about either ourselves in 30 years or we care about our children in 40 years. And I think that's really an important way to think about this, that these are, whether it's through NIH funding or whether it's what we pay for drugs, it's really about an investment in making the world, not just America, but the world a much, much healthier and better place. And so I think it's easy to get caught up in the, well, what are we going to do this year or next year? And I'm glad I'm not on appropriations committee, I get that. But we shouldn't lose sight of the fact that this is really about making the United States and the world a much better place in 20, 30, 40 years. And if we keep on the path that we're on in the last few years, I think we can certainly get there and probably beyond. So, with that, thank you so much for joining us today. And please join me in thanking the great panel.